We are live. Welcome everybody to another How It Works session on CanJS. Today I'm going to be going through what might be the most specialist of special sauce in CanJS, and that is its ability, its can observation, its ability to somewhat magically know when values have changed and reevaluate a function. And produce a new observable that changes when any source observables change. This is, of course, something that like a lot of other libraries can do, like streams can do it, but they can't find their dependencies implicitly the way that CanJS can do. Knockout can do it too. I know Ember cannot. I think Vue can with its computes. I think Knockout was first and we were second, but I'm not actually sure. CanJS had this pretty early. I think Knockout had it formalized much earlier, that like about 6 months earlier than us, but we had it pretty soon after that. Anyways, so this functionality is really in two libraries: Can Observation Recorder and Can Observation. So I'm going to go through each of those, how you can use them, and the source code and how it works. So let's get going. Okay, so we're going to start with Can Observation Recorder. And this is actually pretty simple. This is kind of the mechanism. This is the mechanism in which observables specify, whenever observable value is read, it uses this to specify if anybody wants to know when observable values are read, here's what they need to listen to bind on the value that was just read. And it allows other things like Can Observation to collect all of those kind of, you could call them almost like observable specifications. We call them observation records, to collect all of those, and then they can use those observation records to bind on the actual source observables, and then set up something like Can Observation. So Can Observation Recorder is just a module that exposes a start and stop that allows you to start and stop recordings, an add method that essentially says this observable value is just read, or for an optional key, this key value on this observable was read. You can add multiple observations at once, and you can make a function that even if internally something is calling observation recorder add, those will all be ignored. We could talk about what ignore is used for a little bit later. So like I said, there's really two purposes for observation recorder. The first and more commonly used one is if you're building a custom observable, or if you're a CanJS author, if you're working on define map or can map or can observe or can compute, or pretty much anything that is observable. When a value is read, you call this observation recorder add. And you either, if you're a single value observable, you represent a single value, something like a compute, you just pass in that value. Otherwise, if you're a multiple value observable, then you pass in the like key value pairs, you pass in the object and the key you want to be that you want to bind on. Right? So if I'm going to read map's value, if I'm implementing a map and someone just read its value, I need to call this to make sure that things like observations work. And then the second thing is for things like Can Observation. They can call this start and this stop, and any calls to observation add in between there will be part of this observation record that essentially has all of the key dependencies. In this case, it'll have a map from person to all of the properties. This should be a string in here, to all of the keys that were passed here. And any value dependencies, they just are in a set as value dependencies. So with this, Can Observation is able to essentially bind on all of these and know when any of them have changed and update its value. So that's high-level overview of Can Observation Recorder. Like I already talked about, it's used in Can Defined. like pretty much every observable. Can observation and right now I think React View Model are the only places that really use the other use case, the start and stop themselves to track what observables have been read. If you've got other use cases for that, I'd really like to know them. Other things that you're building. One thing we thought about is like a zoned version of start and stop would be cool to track all asynchronous behavior. Someone please build that. So just a little bit more detail again on how this gets used. Let's say I was implementing my own observable. I wanted to implement something like can map or can define, where this is just going to be an observable with key values, and someone can read get, and it's just going to return what's in this data here. There'd be presumably a set as well. Well, I would just implement this, just make sure that if someone called get, with prop, that I would make sure that I called add to essentially say observe on this observable keys on its prop key. And what the contract is with can observation and can reflect really is that it's expected that this observable key values will implement the get key value symbol. So essentially what can observe is going to call when it sees all these observation recorders and has them, it's going to come back on this observable key values object and use really can reflect to call its on key value symbol with the prop to update itself in the notify queue. Well, to tell itself to be updated in the notify queue. So not only should all observables in CanJS, they must call add if they want to work with can observation and things like that. They also have to implement the corresponding on key value and off key value symbols. So my observable key values above should also have those symbols so that when something notices the observation recorder add and like, okay, now I know how to bind on this, they will come back and use these symbols to bind on that key. Hopefully that makes sense. Cool. Okay. So there's a similar thing that you do for single value observables. Then you don't need to pass a key. You just say, hey, I bind on myself. And you need to implement the on value, off value symbols on your type. So there's just a difference between if you've got something that represents a single value and something that represents multiple values.
There's a question real quick.
Mm-hmm.
John's wondering, can you explain more of what the observation record data structure looks like in memory?
Yes. Let me... Okay, so I kind of actually talk about it here. So what it looks like, I think I do. Yeah, I do. Okay. Okay. So yeah, like I said, there's two use cases, and now this one's going into it even more detail, which is you want to build something like React View Models or can observe, and you want to know between 2 points of time any observable values that were read, and you want to know how to bind on those changing. So you can call observation recorder start and observation recorder stop. And you can see in here, like I've called observation recorder add for prop A and prop B on this observable key values observable, and for prop C on this map. And then I've called for two value-based observables, observable value and full name compute, just observation add with one argument. The observation record that you would get out of this observation recorder would look like this. Let me just see if I can kind of keep it all in frame at once. Okay. So you see here, it's going to be a map, and this is like a, not a CanJS map, but this is an ES map, an ECMAScript JavaScript map that maps, and this is just my way of writing what the key is. The keys in this map is going to be the observable value, key values object, and the map object, and it's it's mapping that object to a set of all of the key values passed. So this one has prop A and prop B, and this one has prop C. And then the value dependencies is just a set of all of the value-based observables that were passed to observation add. So really, the job of like can observation is you loop through your value dependencies and you call can reflect on value on all of these. And then you loop through your key dependencies, and for each key, you call can reflect get key value with each event in the set, with each property in the set. Hopefully that helps. Okay, so let's talk about how this works. Observation recorder is actually really it's really simple, and we should keep it that way because it's stateful, and there can only be one version of observation recorder in a CanJS application. So for 4.0, we really took some special care to try to shore up its API and leave it isolated, so we never have to change this or make as few changes as possible. Hopefully no breaking changes for a very long time for this. So observation recorder, it does have a stack that it maintains, and it pushes, every time start is called, it pushes in a new observation record. There's a little bit of extra information that's there just purely for performance things for some of these other hooks. So when you call start, it adds to the top of the stack a new observation record, and when you call stop, it pops the stack and returns it. Add, because we allow people to set up those ignore and traps and things like that, there's a little bit more logic to it than probably like you would think at first, but really all it's doing is getting the top of the stack. And then if the person didn't provide an event, we're just adding to the value dependencies. I see I still got to clean up some of the, prettify the code here a little bit before we release it for 4.0. But anyways, we just add to the value dependencies if there was no event. And if there was an event, we get the set of events, or we build it, and then we add to the event set for that object in the map. So that's all that does. And that's really all there is to it. Everything else is pretty, like, just pretty much unimportant to really understand how it works. Let me talk about the stack real quick as the final bit about this. So start, I think, shows the stack being used. So it does support a stack, and that's because a lot of times, like if you have a compute inside of a compute inside of a compute, or an observation inside of observations, you don't want it, you want the observation like binding on its child observation, not all of the things the child binds to. So that's why start and stop use this stack. And the same is true with like something like React View Model, where you want a child component to only really see things in its render function, not kind of everything. So that's why there's a stack. So if I call start here and then add something, and then I call start again, and then things are added, they're only going to be added to this thing in the kind of the inside. I indented it purposefully, is only going to be added to record 1. And then when stop is called, anything that observation adds after that point is really going to be back to this kind of first pressed on observation record. So that's why like record 1 only has object 2, but record 2 has object 1 and object 3, because there's a stack there. Okay, so that's really basic. Now let's talk about can observation. Like I said, which I think is really, which provides to people the special sauce of CanJS. If you've never seen it before, you can create observables, and then you can pass to an observation a function that reads those observables, we call these source or dependencies of full name. So person first and person last would be dependency observables of full name. You can read that observable. You can listen to when it changes, and if a source observable changes, then the callback will be called.
It just, this API changed, right? It used to be different, right?
There used to be you'd pass like a third argument here to know when it's called, but we got rid of that. So now you just listen to on and off. And that's because they became kind of they became observables the same way computes are, with the same symbols. So might as well, I decided might as well just give them like a nice user experience like those have as well. Nice API, user-facing API as well. Can observation, for the most part, is low level. Although I think it's going to be promoted to being less so for 4.0. Okay, so let's talk about, so can observation, I think everybody was probably familiar with how to use it here. Some things to know when you're using can observation in 4.0. First thing is name your functions. That's because if you name your functions, can observation, I think I show it, can observation will use whatever name you pass here. We'll use the function's name for debugging and a whole bunch of other things. So like we now name, this is in CanJS 4.0, most of our types have these, well, we call them debugger names. And we try as much as possible to give people a human readable name representing what their type is. And that would also show up in the debugger, which is really nice. What you need to do though is, and most of CanJS when it's building observations does this, but if you're using one directly, you want to give your function a human readable name so that it will show up in the debugging tools that CanJS operates. It'll look nice. If you can't do that, and this is pretty much how CanJS does everything, is if you have a function, you can actually call object define property. You have to use define property for it to work everywhere. You can specify the name property and then a value. And this can even have spaces. And in the stack trace, it'll actually show up as some meaningful name. So this is a way you can provide really nice stack traces for people if you're building CanJS libraries. Which I will say in 4.0, we have taken the time, and there are in many places much more meaningful function names. So it'll help people understand if they run into problems what CanJS is doing. Can queues, a lot of times what you'll see, because can observation is really the bedrock of everything, if you start turning on can queues debugging, you'll see a lot of observation, some name on dependency change, observation, some name update when things happen. What the on dependency change task is that's whenever a task, that's when some dependency of full name changed. And actually, if you expanded this arrow here and looked in the metadata of this task, you would see a reason which would actually tell you which dependency caused full name to rerun. So if this is a situation you found yourself in, and I would imagine that many people have, that I have no idea why this observation or this compute or whatever this part of the page is actually updating itself, you should now be able to see that relatively easily, because you'll see an on dependency change for your observation. You can expand this and you can see there's the reason log on all tasks, and that will tell you the source for that change. Okay, so let's talk about how it works. Okay, so the first thing, so can observation is a constructor and it stores its function and the context. There's some options, which we're not going to worry about here. And really, a lot of the magic that happens in can observation is it keeps a list of its new dependencies in a dependency record. So you can actually ask observation recorder to say, hey, make me an empty dependencies record. That just helps with the diffing that we're going to do in a moment. So it just kind of makes an empty one that you can diff against. And then old dependencies where we'll kind of shift new dependencies to old dependencies, as you'll see. But this is kind of where we track what the observation is depending on. Then there's going to be a method on dependency change where any dependencies of this observation, we want it to call this on dependency change. And we shift calling our internal dependency change just so we have what the this is, the context of what the object that actually changed was. This helps with debugging and things like that, as we'll see a little bit later. And then finally, there's the update method, and this is when the observation actually needs to update itself. And this is implemented down below, but essentially we're just building these because we need them kind of unique for the individual observation. Okay, so can observation now is built with this mixin, this value event binding mixin, which I'll just show real quick here. If you remember from can queues and can trees, if you haven't seen those, you might want to go back and look at that real quick. This is a mixin. Can event queue has mixins for different data types. So if you have something that acts like an observable value, mixin value bindings, you can call it on an object, and it will add methods like on and off, on key value, off key value, make sure it's set up with handlers, make a nice little dispatch method that can dispatch events on it. It's you'll be able to see it down here. It just adds a whole bunch of things, including an onbound and an on unbound method that will get called whenever there are no handlers, or there becomes a first handler, or there are no more handlers, right? So there's a mix-in that can observation is using to make itself seem more observable. If you look at the code for this mix-in, which I'm not going to go into, it's all just key tree stuff and calling the right queues. So we mix that into our prototype. And then the nice thing is once that's mixed in, all we have to do is implement the onbound functionality for the most part, which is what should happen when something is bound to this observation. And this is where we need to read the function and figure out what it's observed, what observables it read, and then bind on all of those. So the code here is a little bit funky, and that's because it's super heavily optimized. This is probably, of a lot of CanJS, this is where I've spent the most time making things fast because computes are used by so much. So what we do is we shift our new dependencies to our old dependencies. So this will just be that empty observation record. We call start. We read our function and keep its return value. And then we call stop to get our new observation record of what we should be bound to now. And you can think of this as what we used to be bound to, which is empty right now. And then we're going to call update observations with this recorder helper. So this is just a function. This is just a external module inside can observation that pretty much is just only used to do this diffing. So we're going to go into how that does that diffing, because this is really the interesting part, I think. Okay. So and this is all written in a way, again, that's trying to be as performant as possible. I am going to heavily abuse the fact that for each can take a context, because I don't want to make another function. I don't want to provide a function here. I want static functions that I never have to regenerate a function. I only have to generate the new context, which is actually much faster. So this is a kind of a performance tip, is like, don't recreate functions if you can get away with it. Instead, use pass data through the this. So essentially what I'm going to do is I'm going to add all observables in the new key dependencies if they're not in old. So I'm basically going through my key dependencies, and for each one of them, I'm going to try. We'll see what I'm going to do. So for each one of my key dependencies, I'm going to get that observable and the set of events for it. I'm going to go through each event, and I'm going to call add new key dependency if not in old. And I'm forwarding along the handler we want to bind, the observable, and the old dependencies set of events for this observable. Right? So these are like the old events that we were bound to for this observable. This is the event handler, and I'm looping through each event in the new dependencies. So what I do is I just check, hey, if the old event set was undefined, that means there were no events, then great, we should bind. Otherwise, if there were old events, we're going to try to delete it. So this actually mutates the old set for performance reasons. Because what we can do is just delete it. And if we were able to, if we weren't able to delete it, that means there was nothing in there. So we're going to, we're going to bind then, right? But if we were able to delete something, that means it was in the old and in the new. We're not going to do nothing. We're going to do nothing. Okay, so that's for the most part what we do, and then we're left with we're left with in the new observable only. Sorry, what we're left with is in the old observable things that weren't bound anymore. So we need to remove those. So we remove observables key dependencies on our old dependencies. So our old dependencies remove key dependencies. Actually, this will go through this. We'll go through each event that hasn't been unbound and essentially unbind them. Questions there? This is some really weird stuff, and it's really weird code to look at. Let me try to phrase it one more time, like in a way that hopefully makes sense. Essentially, we have our new observable, our new dependencies, and we have our old dependencies. And what we do is we loop through our new dependencies, deleting, well, really checking our old dependencies. And if we have something that, if we have a new dependency that is in the old dependencies, we just delete it from the old dependencies, do nothing. If we have a new dependency that's not in the old dependencies, we bind on that new dependency. And then finally, when we're done, the old dependencies is left with whatever used to be bound but is no longer bound, and then we undo all of those bindings. So that's how it works. And that's all this code is doing. It's just doing it on key dependencies and value dependencies.
So it's just making sure that everything that should be bound is bound, and anything that's no longer part of the set gets unbound. Yep,
exactly right. So the
I like that this trick. Like
this trick, yeah.
Yeah, passing like objects and stuff. That happens to me often, where like I have to pass. You know, you have to create a new function just so you can call another function with certain arguments, and you can like kind of, you're using this as an argument. I like that.
Yeah, it's tricky, but it did improve performance like 3%. So when I did it, so it was worth it, because it is like the slowest path of CanJS typically. Okay, so back to can observation. That update observations, all that's doing again is doing a diff of old and new dependencies and setting them up to call dependency change when any of those change. Dependency change it says, hey, okay, one of my dependencies changed. I just found out about it in the notify queue. In the derive queue, I want to update myself. And the reason why we don't update ourselves right away is because, well, maybe there's other things about to notify that something has changed. So we always want to kind of wait till the end of the notify queue before we start running all of these updates.
Is there like a diagram or a chart of like the different queues and what order they run and that kind of thing?
In the queues, one that I showed last time, I showed like a little chart. CanQueues will have a little diagram. Okay, so then update finally gets called, and we still check our, well, are we still bound? Yes, we are, because we don't want to do anything if we suddenly become unbound. Moves the old value, saves the old value. We call on bound again here, maybe because we really, this used to be called just like, this is really just repeating the same process. So when we want to update ourselves, we are essentially going to do what we did when we were first bound, is recall the function and rediff our dependencies. And then this will set this.value again to whatever the function returned. And then we can just check if the values were different, call the dispatch method that the can event queue mixin provides. On unbound, we just need to go through and stop observing all of our new dependencies. It just will loop through and no diff needed there. And then what happens when this observable is read? Now this is where some kind of heady stuff inside can observation occurs. I'll do my best to try to explain it. Well, first, let's just talk about like this is this observation is being read. There's a performance optimization here, which is if observation recorder can tell you if you're actually between a stop and a start call. If you are, we can actually bind to ourself right away, because if we're not bound yet, if we weren't bound, the only way to get a value is to call the function. But then we know we're going to be bound, and then it's going to have to call the function again. So what it does is it actually just binds right away, will unbind itself after a set timeout, so that the value is, bound becomes true, the value is cached, and it just returns the cached value. So this is kind of one cool thing about can observations. It will preemptively, like if you have a compute that's reading a compute that's reading a compute or reading an observation, when the outer one is bound, it will kind of recursively, as values are being read, start binding them and caching their values to improve performance. So you'll see this pattern in a few other observables as well, that they kind of can see when they're unbound and someone is going to be wanting to listen to them anyways, and they will get ahead of it and bind to themselves immediately. Okay, so the final bit is this weirdness in can observation. And if people have a good idea about how to improve this, I would be very happy. So this, I'm not going to go into it in too much detail, but I'd have happy if people want to talk about it. But what can happen is observables try to update in the right order, so that essentially an observable that is like got a bunch of children and there's this whole priority queue thing. Essentially, we try to do them in the right order, so that like parents of other observations are always updated last. But a problem can happen if you have one of those, an observation that kind of switches dependencies. What I mean by that is, let's say I had an observation that did something like this, like did an if some foo, then it's returning bar, otherwise it's going to return Z. it's possible that this observe, CanJS will naturally make it so that this observe will try to be put in the update queue after foo and after bar. It'll always kind of think of it as like take +1 of whatever its children are. However, it could suddenly switch to Z, and then Z might not have been updated yet, but it might be in the update queue, essentially. Because Z might have been notified, put itself in the update queue, but after this observe was put in the update queue. So what we need to do is check, like if there are any tasks remaining, which there can be if you've got a lot of observations updating because of one source change. What we do is we recurse down in this update children and self through our child dependencies to see if any of them are enqueued in the derive queue. This is why that derive queue that we talked about last time has this enqueue and flushed queued task methods, because we essentially see are there any observations that really we depend on all of a sudden. So we need to make sure that they're totally up to date before we return our value. So there's this whole other part of can observation where it recurses through its dependencies to basically check if any of them haven't been updated yet, and then updates them if they haven't. So that's it. That is how can observation works. Are there any questions? I take that as a no. All makes perfect sense.
Well, when you describe it like that, it kind of does. So I don't have any questions, but I feel like I lack a little understanding still, but I'm trying to articulate a question. Anybody else have a question? Well, I think.
Yeah, man. Just the one thing now is, I wish there was a way like you didn't have to have that switch between value types and map or key types. Like, I don't know. It feels weird that something this low level has to know the difference between those two things, you know. But I can't think of how else to do it.
I mean, you could make you could make the alternative would be that there is no key type, really. What you could do is get it so that somehow on the, you know, if it was like if you were kind of pure streams or something like that, and there was only like a channel for value, no air channel. Like a map could always have, like, say, they could have some type of object that represented the, you know, first property or last property as different things, right? And you could pass that to an observation add. Essentially, you have like just an event emitter there. Now we don't do that because of performance reasons, right? And also because of before you have something like CanJS 3.0 didn't have map, the map type, right? So you're using CID and weird hacks to like have a map of objects, which is really weird and difficult. So you try to avoid it and use strings anyways. So it's more possible now that we're saying map is part of.
Yeah, like a descriptor object is kind of that thing, right? It's an object that represents a specific property on an object.
Yeah. So yeah, CanJS, obviously at some point JavaScript had added this type of extra data about every single property, even though I'm guessing that JavaScript, that's not a permanent object, or it's like a lazily defined object. You know what I mean? I doubt they construct all of those every time a property is set. I don't know, maybe they do. But that's the same kind of performance reasons. It's like there might not even be, like sometimes if you read a property on an object, that, especially with proxies, like that, there's no value there, right? That property might not even exist, but we still set up a recording on it in case it does at some point. So that's why we have these kind of two different things. In 3.0, there was only keys, key values, and what it was is things that had a single value, they just said listen on the change event, and they implemented something like add event listener so that it would take a change event. But now with CanReflect, we've tried to like provide like these very concrete steps for everything to integrate. Cool. Well, I don't know if anybody else has any other questions. Thanks.
I have no further questions, Your Honor. Okay.
Thanks for watching. I hope, please like and subscribe if you are watching this. It's really...
I was going to ask one more question. So
okay.
yeah, I've got kind of lost all of the, there's been like an explosion of observable types in CanJS recently. Can you like briefly go over those? I know there's a value one right now.
Well, no, I haven't made that. That was a proposal.
There isn't? I thought there was like a can simple value or...
No, this can simple value, yeah. Okay, if that's what you're talking about, yeah. I thought you meant the can value I was proposing. That's like encapsulation of all of them. So right now, there is a bazillion and a half different observable types floating around in different parts of CanJS. I actually really like that because in 3.0, can compute was trying to be this like one meta, like one-stop shop for all observables that you would ever have to have. And can compute's code was kind of crazy. And now it's, if you want to create your own observable type, I actually kind of walked through what you need to do today and yesterday. You know, you need to call observation add. You need to implement either on key value or off key value. And that's the core of it. Or on key value, off key value, on value, off value. You need to do one of those. Call observation add. And that's pretty much it. If you want to like integrate at like the most basic base level. And then with can key tree, now it's very easy to create your list of handlers. Okay, so great. And then we made can event queue, which does mix-ins. So it makes it even easier. All you really need to do is implement your on bound and on unbound method if you want special behaviors once you're bound and unbound. So instead of trying to like create one Mondo, which we might still do with can value, but it would work very differently where like we have all these very different types of observables now that can each do their one thing and do it well. I actually created which I love, I created a observable for the hash change, a simple value observable for the hash change, and a simple single value observable for push state. So you can actually just get those observables, you can read them, and they hook into, you could do your own kind of routing system based around those now. I really think we should have one for attributes. Like I really think the can atter thing should change into just being able to give you little observables. Because it's, I don't know, it's cool to have that power of like, I've got a totally encapsulated observable object that I can read or write, especially because most things are read and writable. I really like that ability. Cool. Can you all hear the lawnmower running this whole time?
I can now. I didn't notice it while you're talking.
It's been driving me crazy. Of course it runs. Anyways, so what I was going to say is if you like these, please like and subscribe because that's how I know to do more of these. And hopefully, especially like and subscribe if you feel like you're going to be able to contribute more effectively because of this to CanJS. Because that's really the reason why I'm doing it, is I'm hoping that talking about some of these low-level things makes it so if someone's like, oh, I want to add a feature, do something cool, especially right now, you understand the whole observable stack with these 3 presentations. There's really nothing else that one needs to know for the basics of like building your own observables in CanJS. If there's other things people want to know, let me know, because the next thing that I would talk about would be the view stuff of CanJS, how the whole view layer works. So until next time, thanks everybody. Look out for 4.0 soon.